This problem asks us to determine which element is reduced in this reaction. Now, remember, oil rig. Oxidation is loss. Reduction is gain. In a practical sense, we're going to see the redox number decrease as you go from one side of the equation to the other. We're going to see the redox number increase on the other side if it's oxidation. Sorry, I got distracted. My kiddo walked in. One of my kiddos walked in the room. So what we have to do is we simply have to go through and assign oxidation numbers to every element in the problem. So I've got our chemical reaction here that's going all flippy. I'm trying to make it really big here so we have lots of room to work. And let's get to it. So we've got to assign an oxidation number. Let's start with low-hanging fruit first. We've got oxygen in a compound, 2 negative. We have hydrogen in a compound, +1. Oh, whoops, I forgot my oxygens over here. 2 negative, 2 negative, 2 negative. Hydrogen +1. Hydrogen +1, right? Our rules say oxygen is going to be 2 negative in a compound. Hydrogen is going to be +1 in a compound. Next, we look at those fun-filled group 1A elements, and they're normally going to be +1. Another thing we can do is recognize our polyatomic ions. And this one plays a lot with that one. So we've got permanganate, which you've memorized. We should have memorized that permanganate is a -1 total charge. For a polyatomic ion, the sum of those charges has to be equal to, the sum of the oxidation numbers has to be equal to the charge. So I've got a -1 for my charge here. I've got 4 oxygens, each with a 2 negative. I don't have a rule for my charge on magnesium, but I know whatever the charge on magnesium is going to be, I have to be able to add it to a -8 in order to get a -1, right? How do I know that? Because I have 4 oxygens, each with a -2 each. So my only possible value for X is X has to be a +7. So my oxidation number for magnesium is +7. Back to permanganate. Permanganate's a -1, right? So what does potassium have to be here? Potassium has to be a +1. So I've got +1, +7, -2. Over here, I have sulfate. And sulfate, as a polyatomic ion, has a charge of 2 negative, right? So 2 negative charge on that sulfate has to be equal to the sum of the oxidation numbers. So I've got 3 oxygens, each with a -2 charge. I know that because of that 3 there. Plus the charge on my sulfur, which I don't know, has to equal -2. Well, I've got a 2 negative equal to -6 plus X. Well, X then has to be 4. Math. So sulfur there is +4. Again, because the sulfate ion has that -2 charge, we know that my sodium, with 2 of them to counterbalance it, plus this in group 1A, so we know it likes to form +1 anyway, is going to be +1. So I've assigned charges now to everything on the reactant side of the equation. Let's go over here and do the same thing. I'm going to go for some low-hanging fruit first. All the way over here on the potassium hydroxide. Hydroxide is a -1 charge. Potassium has to counterbalance it. So it's going to be a +1 as well. Sodium is bonded to sulfate. I said sulfate over here. This is sulfite, by the way. We've got sulfate over here. It's got a -2 charge, 2 sodiums to counterbalance it. So sodium is once again going to be a +1. So sodium's not changing. We need to calculate the charge on the sulfur here. Let me switch colors again to just kind of make it pop here. We're going to look at our sulfate ion. Again, these are polyatomic ions that you are responsible for memorizing with their charges. There's a reason I tell you guys to memorize them. We've got sulfate with a 2-. We don't know the charge on sulfur, but we've got 4 oxygens, each with a 2- charge, and we know that their sum of their oxidation numbers has to equal -2. So S plus -8 has to equal 2-. So S has to be equal to a +6. So the oxidation number for sulfur over here is +6. So that's one change, right? Over here it's a 4. Over here it's a 6. So we've got sulfur in this equation going from 4+ to 6+. So we've got that one out of the way. Now let's see. Our only element that we still have yet to assign over here is our magnesium. So let's go back. Did I say magnesium? Wow. It is brain stuck day today. Manganese. We go over here to our manganese. And again, we're in a new compound. Compound no charge zone. So the sum of the oxidation numbers has to equal 0. We have 2 oxygens here. So we've got, and here's where things get a little bit dicey. And the book doesn't really do a great job of preparing you for it. But let's roll with it here anyway, and we'll work it this way. We've got 2 oxygens here with a 2-. We don't know the charge on magnesium, on the manganese. Forgive me again. So we've got X plus 2 times -4 has to equal 0. So X plus -4 has to equal 0. So X has to be 4+. So we have manganese going from 7+ over on this side of the equation to 4+ over on this side of the equation. So those are the 2 elements that are changing. Who's being oxidized and who's being reduced? Well, oxidation is loss. So we're looking for the increase. Who's increasing? Sulfur is increasing. So the sulfur is being oxidized here, since its oxidation number is increasing. Then, since we're going from +7 to +4, it's decreasing, and decreasing means that you're undergoing reduction. This was the simple explanation. If you understood that, you're fine. One thing I do want to harp on here, though, is something your book makes a little bit difficult. Let's focus just on this compound. I probably would have avoided this because of that polyatomic ion. What they've done to you here is actually evil. They have hidden a polyatomic ion. And the problem with this polyatomic ion is when you see 2 oxygens, it's not always the peroxide ion. It frequently is, but not always. My guess is here, and we'd have to do the whole problem to determine if this was the peroxide ion. If it's peroxide, it's 2 negative, in which case, for the entire unit instead of each individual oxygen, in which case manganese would have a 2 plus. But either way, you're still seeing your manganese reduced. So it doesn't really matter to the scope of this problem unless we were trying to balance it, but they already balanced it for us. And if we want to walk through the balancing process, which I don't, we could tell for sure whether it was peroxide or oxygen based on that balancing. But that's it for the day. Beep.